And now we are back for problem 512 on page 77. And this deals with a foreman and an injection molding firm admits that on 10% of his shifts he forgets to shut off the injection machine on his line, which causes overheating and increases the probability from 2% to 20% that defective molding will be produced during the early morning run. So the question we're trying to answer is what proportion of moldings from the early morning run is defective? So I've got the start of a probability tree showing right now. I've got a little bit more of it built, but I'm hiding those columns right now. So the first thing we would do is, in this case, for forgetting would be equal to 1.10, meaning that FC, or the complement of that, is going to be equal to 0.90. And again, we can come up here, and if we highlight the C and click the format cells in the lower right corner of the font group, we can just choose superscript with C highlighted, OK, and you can see down here, maybe we'll make that a little bigger. So the idea that you're forgetting to shut off 10% of the time, so that's 0.10, and that means the complement, or when he does not forget, is 0.90. Now what I want to do here is, you see it goes from D to F, so I'm just going to highlight this and under Format choose Visibility, Unhide Columns, and I extended out this. In this case, that 10% of the time that he does forget, the probability goes up to 0.20, where the other times it was 2%. So 0.02 there. And so then we just need to figure out the joint events, which is when he forgets and it's defective, that's going to be equal to 0.10 times 0.20, which is going to be 0.1 times 0.2 equals 0.02. And the other case is down here, where it's going to be 0.9 times 0.02. And I guess I should really put an equal on the end of that, as well as up here, just to make it a little clearer. And in this case, then it's going to be equal to 0.9 times 0.02, hit enter, 0.018. So, what portion of the moldings from the early morning run is defective? The way we get that is simply to go the probability that it's defective is equal to 0.02 plus 0.018, which is equal to, and I'll do the calculation over here. I guess I didn't really need the parentheses with the 0.02 and the 0.018, but equals to 0.02 plus 0.018, and the probability of it being defective in an early morning run, 0.038. So I hope that helps. And now we're going to take a look at 518. So in this case, we're dealing with a telemarketer who sells magazine subscriptions over the telephone. And the probability of getting a busy signal or no answer is 0.65. So busy or no answer probability equals to 0.65, and then that means the probability of the complement of that somebody does pick up the phone is 0.35. But when that happens, when they answer the phone, we've got additional probabilities given that the telemarketer does probably of selling 0, 1, 2, or 3 magazines. And I'm just going to use AutoSum here to show you that that equals 1. So those are the only options available. It's either going to be, they're not going to make any sale at all, which is 0.5, 1 magazine 0.25, 2.2, and 3.05. And again, these probabilities are all part of this 35%. So if we're trying to calculate what the total probability of no sale is, let's calculate based on the fact that contact was made. So we're going to go 0.5 equals 0.5 times 0.35. And I really should put that in parentheses. Didn't like that. There we go. Which is 0.175. But that's not totally it, because we need to add in this 0.65 because we didn't make a sale on those either, because we didn't even get to talk to them. It was busy or no answer. So if we go back into this formula and go put parentheses around that, plus we add in the 0.65, then we see that it's 0.825. Now this is a case where the probability tree probably would be helpful. So let's insert one of those just to show it to you graphically. I am going to insert the shape being the line, and I'll draw it starting right here. So I'm just going to draw up first, put in another line going down, and then in this case we'll do another straight line across. I'm going to hold down my shift key and put in another one. And in this case, we're going to have the probability of B, which is busy or no answer, equal to 0.65. And then down below here, the probability of BC, which is the complement, equal to 0.35, and I'm going to fix that up here so you see that it is a complement again. hit the superscript just to make it easier to follow. And now we can go and continue on adding to the probability tree. And in this case, I'm going to click on the Format tab, and I need to add 4 items to this tree then. So I'll go up quite a ways here for the first one. And then I'll add a second right there. Click on line again. Put a third right there. And lastly, I'll put the fourth one down here. And then I'll add in some straight lines. So as I go over it, again, just click on line again. Almost done with it. So in this case, it's going to be 0 given BC, and that's 0.5. Now I'm going to go up here on the C, highlight it again, and make that superscript. And I actually just could copy this and change it. But down here, I'm going to make it 1. And it's going to be 0.25. Copy it again down below. In this case, it's going to be 2, and the probability there is 0.20. Oops, too many decimals in there. And the last one would be 3, and the probability of that is 0.05. And the question is, again, what's the probability of no sale? And in this case, I'm going to calculate that by going equals to 0.35 times 0.5, and that gives me 0.175, and I take that and add it with the 0.65, and so you see there that it's 0.65, 0.175, and add those two together, and it's still the 0.825 that we saw the other way. It's just here you see the graphical representation of it, and I could tweak that line a little bit, make it line up. So hopefully that gives you a little more insight into how this problems work. Again, all of the answers for the even number problems are found at the end of your book.